In this video, I'm going to look at how you can compute the logarithm of a number several ways using some formulas, using the graphing calculator. In this case, I'm using the TI-84 Plus. So first, let's look at the definition of a logarithm. So here it is. The log of some number x to some base b is equal to L means or implies that x has to equal to the base taken to this power L. So you can see here by this, L is an exponent. So we can say that the logarithm of a number represents an exponent. Conditions that have to be satisfied: first of all, the base has to be positive, cannot equal to 1, and the number you take the log of has to be positive, cannot be 0, cannot be negative, and the exponent or the logarithm L can be any real number. So first, let's look at the definition. First, let me point out here that for this log of x to base b, if no base is indicated and they're using log, then the base is understood to be 10. Okay. Otherwise, they'll use ln, which is the natural log, and that's the log to base e. So let's look at the calculator first. So on the calculator, you can see we have the log function here. We have ln. So if I hit that function and enter any number, say 55, and hit enter, that computes the log of 55, which is 1.7 to 2 places, 1.74. So that's basically telling me that if I take 10, because 10 is the base here, it's understood. If I take 10 to the 1.74 power, that will give me approximately 55. Okay. Now, if I use ln, now I'm using a base of e, which is approximately 2.72 to 2 places. So if I enter any number there, say 41, close the parentheses here, that gives me 3.71 to 2 places, 3.71. So that's the logarithm of natural log of 41. So what that number represents is this: if I take the power, the number e to the 3.71 power, that would give me approximately 41. Okay. So now let's look at the examples that I have here. Now, in some cases, you could have exact answers, so you don't need a calculator. So, for example, here it's the log of 1,000 to base, no base written there, so that's 10. So 10 to what power will give me 1,000? Well, it'd be 3. Okay? So that's the answer. The next one, again, this one will have an exact answer. Won't give you a decimal. The log of 32 to base 2 is what number? Well, first you figure out 2 to what power will give me 32? Well, 2 to the 5th will give me 32. So the answer would be 5 without using a calculator. The next one is natural log, ln, remember the base is e. So in this case, e to the 5th is equal to e to what power? Well, 5, right? So no calculator needed. The base here is 5. So when these are the same, and the base and the number here, this base here is the same, the answer is going to be the exponent. Okay? Now, when you don't have an exact answer, and you don't have a base of 10 or a base of e, then you can use a change of base. Here, of course, ln of 75, no problem there. I just hit ln and then enter 75. That gives me an approximation. Okay, so the logarithm is 2 places, 4.32. Okay, now let's go to the next one. Suppose you want the log of 41, but see, now we don't have a base of 10 or a base of e, we have base 3. And that doesn't give me an exact answer, like the first one, or the second one, or the third one that I have here. So if I use this particular base here, or this particular formula here, this is saying if you want to compute the log of some number x to some other base, other than 10 or e, you can use this formula. So what does it tell me? It tells compute the log of the number x, pick another base. And of course, the base you want to pick is one that you can use, take advantage on your calculator. So you would use base 10 or base e. So I could figure out this problem here, log of 41 to base 3, enter, say, either one. I'm going to use log to base 10. So this is saying log of 41 divided by, okay, the log of whatever the base is. That's what this is saying. See? This base right here, whatever this is. Okay, so the base here is 3. So enter 3 there. So the log 41 to base 3, using this is called the change of base formula, is to 2 places 3.38. Okay, clear this. The next one again is the log 571 to base 7. Okay, so again, using the change of base formula, now I'm going to use ln, okay, base c. You can use log base 10. So here, say, formula says it's the natural log of whatever this number x is. So in this case, it's 571. So it's 571. And then that's divided by the natural log of whatever the base is over here. Okay, that's base 7. So enter 7. Hit enter. So the log of 571 to base 7, if you round it out to 2 places, it'll be 3.26. Now, this particular calculator has a built-in formula. So notice here, if I go to math, and it's way here, it's way at the bottom over here. I'm going to go up to get to it quicker. And here it is, right there. So hit enter. So it's set up now. We want the log of some number to base whatever it is. Okay. Now let's do the first one we had was 1,000. Okay, so the base, it was 10. So here we indicate the base, whatever it is. In this case, it's 10. That was the first problem I did here. And enter 1,000. And of course we said the answer was 3 without using the calculator, because 10 to the 3 power is 1,000. So no problem, we get 3. Now the last two, again, if we don't want to use a change of base formula and we have this particular calculator, or a calculator that has this formula built in, then we go to the math menu, we go up, okay. There it is. So let's suppose you want to do this one here. The log of 41, the base 3, so enter the base first. Okay, now the number, 41. Hit enter. And we get 3.38. Okay, you can do it with a change of base formula also. Let's just do the last one here. Again, go to math, and again I'll go up here to access that formula. There it is. Hit enter. So now let's quick compute the log of 571 to base 7. Enter the base first, and come over here, 571. Hit enter, and we get the 2 decimal places, 3.26. So this gives you several options here when you want to compute the log of a number, especially if it's the log to some other base other than 10 or e. Okay, thanks for watching. We'll see you next time.